Hello everyone, this is Pranav Bansal, and today I'm going to be talking about how you can make and train different models, different machine learning models on a given data set of your choice. So the data set that we have taken here today is the weather data set of the Szeged city of Hungary, and it's the 10 years of data from 2006 to 2016. It's available on Kaggle. You can go and search for it. So the first thing that obviously we need to train our model on a data. So the first thing that we require is the data. And before feeding it to the model, we first need to do some pre-processing on the data. We have to check if there are some missing values or if there are some values that need to be deleted from the data set. Uh, so first we have to check for those values. And after we have done our processing on the data, then we feed it to the model, and then we check our model with the new values. So the models that I'm gonna be uh, using today are linear regression, polynomial regression, cart regression, and the random forest regressor. Now, what we are gonna do is we have okay. Let's first have a look at the data. I have the data file here. That's a CSV file. So we have the data recorded, weather data recorded for every hour on a particular day. So it's like for day one. So we have day one at 12 o'clock, then 1 o'clock, 2 o'clock, until 12 at night, like that. And then we have summary and precipitation type if there is some kind of precipitation on the day, or temperature for the day. This is what we are going to be predicting using our model. And then you have apparent temperature, humidity, and many other columns. So now let's first, this is our data, and so this is how you can get the columns of the data using the data frame attribute. And the shape, this is the shape of our data set. We have 96,453 rows and 12 columns, and not all of the columns are useful, so we'll have to drop some columns eventually. Okay, so dot describe attribute, it generates descriptive statistics that summarize the central tendency, dispersion, and shape of a data set's distribution, and it excludes the null values. Okay, so let's see here. Now for the temperature column, the number of entries that we have in that column are 90,453, which is same for every column. And the mean of those values for a particular column is this. This is the standard deviation, this is the minimum value, this is the maximum value, and this is the lowest 25 percentile values. These are the top 75 percentile values, and this is actually, you can say it's like approximately equal to mean, the top 50 percentile values. And now we'll look for the df.info attribute. What it does is it prints a concise summary of a data frame. So here we have it gives us the number of entries, and we have 12 columns, then number of entries in a particular column, and if we have some null, if there is a column which has null values, and the data type of the column. Now what we have to do is, if we have null value in a cell or in a particular column, then we can't directly feed it to the model. We'll have to do some processing on that null value. We'll have to delete it, or we'll have to replace that value with a value which makes more sense and which is more reasonable. So what we'll do is, first we'll make a search in the column using the dot is null dot any. If there's any null value in a particular column, then this will return true. So here, as you can see, all the columns except the precipitation type return true. written false and precipitation type returns true. So that means there are some null values in this column. Now we'll check if all the values in this column are null. So this we can do with the .all attribute, but it's false. So there are some of the values in this column are null. So that means there is no data for the precipitation type on that hour of that day in that column. Now we'll calculate the percentage of the null values in that column, which if you'll do the math, you'll find it around the number of entries will be 500. So that's actually 0.54%. So 0.54% of the entries in the precipitation type column are null. So we don't have any value there. Now for that particular column, we'll count the number of different values. In precipitation type column, we have rain and we have another value is snow. So there are 85,224 entries for rain and 10,000 something values for snow. And the rest, which I said earlier, the 500 entries are null. So we'll have to replace those entries with a value which makes more sense and which will help our model to train better on the given data. Now, as you can see that rain is occurring quite more than snow. So what we can do is we can just replace all those null values with rain. So we can assume that the hours for which we don't have a data, the precipitation type was rain. And now we'll again check for the null value percentage, and because we have already replaced the value, so the null value percentage should be 0, as we can see here. All right, so another thing that we have to take care is we cannot feed non-numerical values to our model, because come on, it's a machine learning model and machine cannot work on just strings. They need numbers to perform their mathematical calculations and then predict some output, some useful result that will help us. So what we'll do is, because we only have two values in the prediction precipitation type column, so we'll replace one value with 1 and another value with 0. So we replace rain with 1 and snow with 0. And one more thing that we should see is this summary column is not useful for us, and this daily summary is also not useful. So we don't need those columns for our model. So we don't need to feed those columns to our model. And we have all the columns except these columns are numerical. So we don't have to bother about them. But this precipitation type column, we have replaced its values by binary values 1 and 0, which will make our computation calculation easier. Now, the next thing that we have to do is we have to separate our training and testing dataset, and the feature that we are going to predict is the temperature. So we'll finally, when our model will be trained, what we'll do is we'll provide it a set of features with their values, and then we'll ask it to give us the temperature. What's the temperature? What would be the temperature according to the model if these are the other conditions? These are the values of the other features. So what we want to do is we want to predict the temperature. So we'll take it out of the data set, and another thing that we have to do, and the weather underscore x will be our data set on which we'll train our model. Till now, we have done all the required processing on our data, and we have imputed the missing values as well. So now our data is ready to be fed into the model. So in supervised machine learning, what we do is we give the model some data and we tell it that this will be the output for it when these are the conditions, and from from those features the model learns, and after that it is able to predict some output for a new value which it had never seen before. So what we have to do is we have to split our data set in train and test, and that's how you do it. We have to predict the temperature. Weather underscore y actually contains the temperature column as we did it here, and weather underscore x is our the whole rest of the data set. Now we have to split the data set, and then we'll have some data set for training and some data set for testing. So this is just a visualization. This is our train underscore x data set. It has my all the rows, all the columns except the temperature column. And similarly, my test data set, the test underscore x data set, contains these the values for these features, and test underscore y contains the temperature when the condition corresponding to these conditions, and train underscore y contains the temperature, obviously. Now sometimes we are really confused because we have studied a lot of math behind these models, and that mathematics confuses us. It gives an illusion that it will be very hard to implement a model by ourselves. So you don't actually need to worry about it. Python has already provided you with the inbuilt libraries that we can import and directly use. So I have actually imported it in the starting. Yeah, here we go. So from sklearn.linear underscore model, import linear regression. That's it. That's just literally one line of code, and you got the model in your hands. You just need to train the model. So now we have the model and we have the data, and it's time for training. All right. So the first model that we're going to train is a linear regression model, and we have imported it earlier, and now we can directly use it. So we'll train our model on the train underscore x and train underscore y values, and once it's trained, we'll try to get the output on the test underscore x values, and then we'll compare those values from the test underscore y values. So there will be some prediction. Our model will make some prediction for the temperature when it will be given the input features, and then according to its learning, it will give us the temperature. Now for this is for we'll calculate the error. We'll check how much difference do we have in our predicted values and our actual values. So in this case, the error is around 0.901. So which is actually much, I would say, because if we analyze the data file clearly, then we'll see that the temperature variation for this Segit city is not much. So even if like your model has an error of 1 degree Celsius, then it would not be a very good model. It's not good to have a error of 1 degree Celsius. And this is just a visualization of what our model predicted and what the actual values were. So at some day the temperature was minus 2.2 degrees Celsius, and our model predicted minus 3.3 degrees Celsius. So that's a difference of whole 1 degree Celsius, which is not good because the temperature variation is not much, I would say. So that was our linear regression model, and now we'll move on to our polynomial regression model. So again, we can just simply import the polynomial regression model. Actually, polynomial regression is nothing but we just train our linear regression model on we just transform the train underscore x data set, and then we train a linear regression model on it. That's polynomial regression. That's how we can implement polynomial regression here. So I'm not gonna go deep into the mathematics of it. I'm just gonna talk about how you can simply implement these models and compare them. again we'll now all the steps will be similar. We'll train our polynomial regression model, and then we'll check for the error. So the error that we got in this case is 0.09, which is quite less than the previous time. So earlier we had an error of about 1 degree Celsius, and now we have it's just 0.09, which is quite less than the previous time. So you can see the temperature was minus 2.2 degrees Celsius. It predicted minus 2.28 and minus 2.29. So it's quite a good prediction. So that this model is pretty much better than linear regression. Okay, all right. So the next model is our card, the decision tree regressor. Okay. So one more thing that I wanted to talk about is there are so many attributes that are provided to you for a model, for the structure of the model. So you can actually modify them and train different versions of the same model on the data set, and you will get a different output every time. And then from those versions, you can actually select the best model which fits your data the best. Uh, and another thing that you have to take care of is that your data should not overfit the model, because it will make your model very specific to that data set. And whenever it will encounter some new value, it will give some out of bound or very abnormal prediction, which is not good. So you should always take care that the model is not overtrained. And yeah. So now this is our decision tree regressor, and the error that we got in this case is 0.008, which is more less than polynomial regression. So like for example, the actual value was minus 2.28, and the predicted value is here minus 2.26, which has a difference of a very minor value. So it is a very good prediction. All right, so our next model is random forest. So earlier models I have only implemented a single version, but in this model, just for your understanding, I've implemented two versions of it. So the first version has a maximum depth 10, and the second version has a maximum depth of 50. Now, so if I trained this model, then I got an error of around 0.008, which is actually similar to our previous model, which was our decision tree regressor. And when I train it with a maximum depth of 50, then the error that I got is 0.001. So it is more less than the previous version of the model. But yeah, as I've talked about earlier, we always have to take care that our model should not overfit the data, because we have to generalize it. So we have, according to our requirements, we should select the best model. Okay, so let's give an analysis to the error values in the last. The error that we got in our linear regression was 0.902. That's around 1 degree Celsius. In polynomial regression, the error is 0.09. In decision tree regressor card, we got an error of 0.008, which is approximately equal to the error in random forest with maximum depth 10. And in random forest with maximum depth 50, we got an error of 0.002. So according to our short analysis here, as we compared different models and different versions of it, the best model that we'll choose for this data set, the weather for Segit City data set, is random forest for with depth 50. And this was all. That's the comparison between all the different models. You can try implementing some models with different versions, and then you can compare it yourselves. So we can conclude that actually machine learning is not that hard. You just have to have some basic understanding of the concepts. And then the important part is data pre-processing, which is very, very important because it will affect the prediction of the model to a great extent. So you should always take care that your data pre-processing is very good and you have perfectly taken care of the missing values or the null values. And once you have imputed all your null values and you have dropped unnecessary columns, and if there is a column which is useful and it has string data in it, then you should binarize it and use some numerical values to depict the values, whatever. So that's how you can do the data processing, and then you can feed it to the model, and you can simply the model, as you see, like training the model was just 3 or 4 line of code, and then you can get your output for the test values. So it was very pretty easy. That was all. Thank you so much for watching the video.